Hi everybody, welcome back to another MyTutor online school tutorial. Today it's GCSE Maths and we're covering kind of the financial maths side of things, so simple interest and how that's different from compound interest, and a lot more percentage change stuff and some money problem questions. So today's session is 1 hour long, so it will finish at 12 at midday. Just checking what time it was. So this is me, Molly, who's leading this session. I'm just finishing my second year studying computer science and maths at Bath, and I've done a lot of sessions with MyTutor. So a couple of things. First of all, at the end, we'll again be sharing a link like we did yesterday to a survey. It's really important for us to know how you're finding these sessions and get as much feedback as we can, because we want to change our approach and know what works for you guys. So I'll let you know when that link has been made available, but please do fill it out. It does not take long at all. The other thing is, throughout the session, please do use the chat and Q&A functions of Zoom. It really helps me to know that you understand, that you're with me. Feel free to pop your answers to questions in there, because I'll explain why any wrong answers are wrong. Yeah, and I think that's everything. So we're going to get started as per usual with a Kahoot at the beginning. So let's grab that one up. So we've got one at the beginning and one at the end. They both have I think the same amount of questions. They're exactly the same difficulty, really similar. They're just different numbers. Yeah, so that you can't remember the answers from the first one. So let's go for it. First one. Cool. So go ahead and join this one. So whilst you're joining, the format for today is we'll do this Kahoot. And then we're first of all going to do some simple interest questions, explain what that is, then look at some VAT questions, how to add that. And then I've got a whole worksheet of loads of money problem questions that we'll look at. So the first half of the lesson is probably more foundation based. And then the second half of the lesson will be about percentage change and how this applies, especially to money problems. And that will venture more into the higher territory. It will be looking at similar stuff to we looked at yesterday, but a lot less confusing. And it will be using the concept of multipliers a lot, and stuff like that. So I think I might go ahead and get going. There's 19 people, so that's pretty much everyone. So what I'll do is, as per usual, I'll pop this in the chat and leave it unlocked so that you can so that you can enter as you're doing it. Oh, someone's just asked to wait. I'll just give it a tiny bit longer. Okay, I'll start now, because as I said, it's most people. But you can join throughout, so don't worry. Okay, so just a true or false to start with about what simple interest and compound interest are. Don't worry if you don't know. This test, you're not supposed to know. This is for me to assess whether you know stuff or not, and what level we're currently at. So. Cool. So yeah, this one's an interesting one. And we'll see what the simple interest formula is and why this one is actually true. So a little simple interest maths question. brilliant. Yeah. So it's just 10% of this. And we'll see how to do that really quickly in one calculation. So this here means per annum, so per year. This one is simple interest as well. So don't worry if you don't know how to calculate simple interest or you're not sure exactly what it is. You will do by the end. Okay, let's go to the answers. Okay, so this is taking 5% of this and adding it on 10 times. So we'll, again, see why that is properly at the end. Okay, this is about percentage change now and how we can do that. So if you came yesterday, hopefully you'll know how to do this one. I'll explain it all again today and a lot better and more clearly because more of the lesson focus is actually on that. Okay, brilliant. Loads of people got that one and we'll see how to do that throughout the lesson. So this one's the percentage increase now. And we'll see how to do this in just one calculation on a calculator in this lesson. Excellent, loads of people already know how to do that, fantastic. And finally, a bit more of a word question. I'll probably skip this when this gets down to 30 seconds, so try to get your answers in by then. Okay, brilliant. Again, loads of people getting that one, which is perfect. And I'll be going through questions just like this throughout the session. So in third place, Smart Dude. Nice. Second place, oh, and the top two got 6 out of 6, which is fantastic. And Emma. So well done, guys. Yeah, did really, really well on that one. I think simple interest is definitely one to go over based on that question, which is good because that's what we're covering first. So average percentage, 45%. Nice. I mean, that's already fantastic. So hopefully we can get that up by the end of the session. Okie dokie. So let's get going. So we're going to start off with simple interest. So the one that you're probably most used to doing is compound interest. And if we just have a quick reminder of what compound interest is, the formula for this is A, lots of 1 plus m to the n. So basically you take the original amount, the increase multiplier, and you do it to the power of how many years it is. So for example, if we have, in fact, why don't we do the same question with compound interest and then see how it's different with simple interest. So £100 in a bank with interest 5% per annum, so per year, for 10 years. So compound interest, we take that original amount, we are increasing it by 5%, and I will explain this concept of a multiplier when we get to percentage change, because this isn't used in compound interest, so don't worry about that. So this is our multiplier for an increase of 5%, and then we do that to the power of 10. That's just this formula. A is 100, this is 1, m is 0.05, and n is 10. So hopefully that will make sense there. So someone said, what's n? N is the number of years that it is kept there. So the number of times that increase is applied. Yeah, this is compound interest. This is just a reminder of compound interest. So this would give you, let me get up my favorite online calculator. So, oh, that's not a calculator. There we go. 100 times 1.05 to the power of 10 gives us this. So £162.89. Cool. So simple interest all depends on the first amount that you put in there. So this is never really used in the real world. But it is in exams and in some circumstances. So simple interest is you take the very first amount, so that very first 5%, and you just add that the number of times. So it's actually simpler to calculate, and simple interest could even be on a non-calculator exam, because you don't have to raise any multiplier to a power or anything like that. You can just, yeah, it's a lot easier to calculate, and I'll show you how now. So simple interest, the kind of formula that we use for it, is A plus, let me try to think what I'm gonna do for this. N lot, so the number of years. Call this AM, and I'll explain exactly what this means. So A is the original amount, and then we do n lots of basically 5%. So all of these are the same as the A, M, and N here. So M is the multiplier. So the reason that we do AM is because this tells us 5% of the original amount. And I'll show you with this example here. So we're going to do 100, and then we add on the amount of interest that we earn. So that's for 10 years, lots of whatever 5% of 100 is. Now we can see that that's 5. But the way that, what I mean by AM is that what we've done is 100 times 0.05. That this is how we easily find a percentage of a number. And I will be covering this properly later in the lesson. So all AM means is whatever the percentage is of the original number. Hopefully that makes sense. So the answer that we'll get for this one is, so this is 100 plus 10 lots of 5, so 50, So this one's 150. So see how we get completely different answers for compound interest and simple interest. Compound interest, as I said, is what is used in the real world, because simple interest relies wholly on the original amount that you put in. And that wouldn't work in the real world, because sometimes people suddenly get a lot of money and then all they would do is take it out and switch to another bank to start earning the interest on that money. But it is used occasionally, maybe with smaller loan. If you take out a specific loan, I think that this is probably used. I'm actually not 100% sure, but it is used, just not as widely as compound interest. But it is really important to know the difference between them. So I'll give you guys one to do. So let's say, and try to do this one non-calculator if you can. But don't worry if you can't. If you need to work out the percentage on a calculator, it doesn't matter at all. So I keep £250 in a bank with 10% simple interest for 7 years. How much do I have at the end of 7 years? So give this one a go and see what you end up with here. Yeah, a couple of people getting that really, really quickly, which is fantastic. Okay, I think a lot of people have answered that one now, which is good. Okay, awesome. So let's think about our formula. So we've got A plus n lots of AM. A plus NAM. So our original amount, and then we add on to that our 7 lots of whatever 10% of 250 is. And 10% of 250 is 25. So we can do that non-calculator, because to find 10% of something, you just divide it by 10. So 7 times 25 gives us 175. And then we add these together and we get 425. So the majority of people got that, which is fantastic. So yeah, well done. If you didn't, do you understand why it's this one? I think someone said, can you re-explain it? I'll do one more example and explain that one again, rather than re-explaining the same one. So let's have a look here. If this page wants to respond to me. There we go. Let's do one. In fact, why don't I find one from one here? Okay. Oh my gosh. There we go. So you deposit £400 in a bank, paying 5% simple interest per year. So this one is how much interest would you have earned after 3 years? So think about how that's different and give this one a go at answering. Cool, loads of people getting this one, which is fantastic. Awesome, so I'll go through this. So one way that we can think about this is use the same formula. A plus n lots of AM. So our original amount at our 3 years, and then 5% of 400, which is 20. And then notice that this is our original amount. This bit is the actual interest earned. So we only need the kind of the NAM part of the formula to see the actual interest earned, which everybody did. So it's £60, which I think everybody who answered it got, which is fantastic. So yeah, really well done. Awesome. Okay. So hopefully that all makes sense. And we can always come back to them if people want to. But for now, we'll go on to some generic money problem questions. So for example, stuff like this. So this one here says that this could be in higher or foundation. It would probably be one of the earlier questions in a higher paper. But give this one a go. They're often, oh, did I not copy it? Doesn't seem to be pasting. That's better. Okay, I've run out of room on this page, I think. That's better. So Steve wants to put a hedge along one side of his garden. He needs 27 plants, which each cost £5.54, and he has £150 to spend. So does he have enough? So what do you guys think? How can you do this one? Oh, a couple of people have asked for one more simple interest question. Sure thing. After this question, I'll hop back onto that. Thank you for letting me know. Yeah, people are getting the right idea for it. So the main thing about these is kind of the way that you write them out. You always have to write your maths explaining every step. Never assume that anything's obvious. So what I always do is write it out really, really super clearly. So for example, I would say total cost of plants is, well, he needs 27 lots of this £5.54. So we see what this gives us. 27 times £5.54, £149.58. And then you have to say £149.58 is less than 150. So he does have enough. So it's just this kind of writing out things, even if it seems obvious that 149 is less than 150, you've got to write it out really clearly so that you know everything, yeah, what's going on is super clear. Cool. So let's do another simple interest one. So let's do one with a bit of a trickier percentage, shall we? So you can try this non-calculator or do it calculator. It doesn't matter. This one. So let's say I put £520 in a bank with 6.5% simple interest per annum. How much do I have at the end of 11 years? So give this one a go, another simple interest question. Just remember to write out the formula and just apply it to less than that. Someone said that question didn't have anything to do with interest though. No, so these questions are a mixture of just kind of financial maths. So just like money, word problems, and simple interest, which is one branch of financial maths. So I'll let a few more people answer this. Okay, so let's give this one a go. A couple of people are answering it. A lot of people seem to have different answers, so we'll see what it is. So the first thing that we want to do, let's recall our simple interest formula. So A plus NAM, so our original amount, and we add on the simple interest that we earn. So 11 years worth of 6.5% of 520. So to find 6.5%, we can either find 1%. So let me show you how to do this non-calculator. So we could find 1%, which is just dividing it by 100. So £5.20. And then we can find 6% by just multiplying that by 6. So that's £31.20, I think. I hope. Yeah. And then we can find 0.5% by just halving the 1%. So that's £2.60. And then we can find 6.5% by adding the 6% and the 0.5% together. So we get £33.80. Hopefully that makes sense as to how I did that one non-calculator. Don't worry if it doesn't, but I can always re-explain it. So that's the number that goes in here. Now this is a difficult one to do non-calculator. So I will just do this one on the calculator just to save some time. But you could do it using column multiplication. So 11 times 33.8 gives us 371.8. And then we add 520, so add our original amount. And we get £891.80. Cool, so a couple of people got that, but because there were some different ones, I'll do at least one more. We've definitely got time today to really nail these topics home. So let's have a go at another one like this. So, okay, I keep, let's say, let's do a bigger amount, £775 in a bank with, what should we have? 5.9%. So this you'll definitely need a calculator for. Simple interest per annum. How much do I have after, let's give it 21 years. Let's say you put it in when you're born and you leave it there for 21 years. And when you're 21, you take out all the money. So if you're not, because I haven't explained multipliers yet, the way that you find a percentage of something, let me just explain this quickly before, just in case you can't tackle that one. Say we want to do 25%. You can turn that into its multiplier, which is just dividing it by 100, so 0.25, and then multiplying that by whatever. So if the question said 25% of 70, that's the same as saying 0.25 times 70. So if we want to do, say, 7.5% of 100, that's the same as saying 0.075 times 100. Does that make sense about the multipliers and how to find percentages? Because you'll need that for answering that question. Does this make sense, this multiplier? Just let me know in the chat. Okay, perfect. Brilliant. Yeah, so use that knowledge to, finish giving this question a go. A lot of people have sent in their answers. I'll just give it a tiny bit more time in case anybody else wants to give it a go. And then I'll go through how to do it. Okay. So again, there are a few different answers. There's a bit more agreement this time. So let's have a look. Let's remember our formula. A plus NAM. So we do, and this is where the AM comes useful when it's like this. So we take our original amount and we add on 21 for the number of years. And then this is where, so AM, remember, represents 5.9% of 775. And the way that we do that is by doing AM. So remember how I said it's this times the multiplier for it. So this is what AM means, and it's just what I was doing on this screen here, working it out using the multiplier. So this just represents 5.9% of 775. So let's go ahead and pop this into a calculator. So 0.059 times 775, and then multiply that by 21 for the 21 years. And then finally, add on our starting amount. So if you just, I could have just put this all in one go, to be honest, and we end up with this, 1735.225. Important thing is to round it to 2 decimal places. Whenever we're talking about money, it's always 2 decimal places, because that's how money works. You always have your amount in pounds and then pence, which is 100th of a pound. So this will be 1,735 pounds 23. And this will be our final answer here. So does anybody want to do any more of those? Would you like to do some different money questions, more about percentage change? Okay. Majority is saying no. So I'll leave it. 1 or 2 people have asked for one more. There are a couple in the Kahoot. So because, oh, people are saying on the Q&A though, one more. Okay, I'll do just one more and then we'll move on. But yes, this really will be just the one more. So let's see if everyone can agree on the answer this time. So, oops, if I can use technology. So I put £300. Try this one non-calculator as well for a bit of an extra challenge. In a bank with what are we going to have? 4.5% simple interest per annum. How much do I have after 5 years? So give this one a go. Cool, a couple of people have got it. Brilliant. So everybody sent in an answer now. Everybody's saying the same thing, which is fantastic. So this is good. One more was clearly worth it. Double check. Excellent. So we do our A plus NAM. So 300, and we add on for the 5 years, and we want to work out 4.5% of 300. So if we're using a calculator, we do 300 times 0.045. If we're not, we do it in a really similar way to before. We work out 1%, which is just by dividing it by 100. We use that to work out 4%, which is just multiplying that by 4. And then we work out 0.5% by dividing the 1% by 2. And then we find 4.5% by adding those previous ones together. So £13.50. So then this becomes 300, add on that 5 lots of £13.50, which is 300 add, I think it's 67.5. So we get 367.5. And a couple of people did this, which is really, really good. Whack an O on the end. Make sure that it's 2 decimal places, because that's just how money is written, as I said. But that was brilliant. I think every single person who sent in an answer got that right. So that's really, really encouraging. Well done. Okay, fantastic. So we'll start the Kahoot again in about 5 or 10 minutes. But for now, let's just have a look at some more of these generic money problems here. Okay, so before we do this one, I just want to talk a little bit more about multipliers. So we did cover this slightly yesterday, and I think we have done it before as well with percentages, but this is really important, so there's no harm in going over it again. So multipliers we can use to do percentage increases and decreases in just like one step. So for example, increase 560 by 12%. Well, first of all, who can tell me the multiplier for just 12%? Awesome. Some people are already getting the answer, which is fab. So yeah, the multiplier for just 12% is 0.12. So if we wanted to find 12% of 560, we just multiply it by 0.12. And then to increase it, we add that back on. But the way that we can do this in one step is that the multiplier for an increase is the multiplier of the percentage added onto 1. So the multiplier for an increase of 12% is 1.12. And then we can just do 1.12 times 560 to give us the answer in just one calculation. So 1.12 times 560 gives us 627.2. Does that make sense, how I found that multiplier? Loads of people are getting it, so that's fantastic. So a decrease, we subtract that multiplier from 1. So if we wanted to, decrease 450 by 15%, what would be, you can say the answer if you want, but I'm more interested in what would be the calculation. So what's the multiplier for a decrease in 15%, do you think? Awesome, lots of people getting this. Someone said, how do you remember this? I guess about the multipliers and stuff. Just practice, I guess. And the other thing is, the reason that it works is because when we multiply by a multiplier and add it on, that's the same as multiplying it by an extra 1. I guess just practice and tackling loads of these kind of questions, it does become really instinctive. So don't worry about that. So yeah, loads of people have said it. So the multiplier for 15% is 0.15. So the multiplier for a decrease in 15%, we take that away from 1, and we see that it is 0.85. So we can just multiply 450 by 0.85 to do this in one step. And we get 0.85 times 450, 382.5. And loads of people were getting that, which is fantastic. And this is super, super useful. We can also use this for reverse percentages. So we'll have a look at one question on reverse percentages, the final word question I have, and then we'll do the Kahoot. That's the plan for the rest of it. So reverse percentages is stuff like this. So let's say I bought a dress in a 20% sale for £62. How much was it originally, so before the sale? So does anybody have any ideas about how we can do this one? Okay, so the way that we do this is we call the original amount X, just so that we've got something to work with. And then we think about what we would do to decrease that by 20%. And a couple of people said it'll be 0.8. So what this is original amount times 0.8, so we're decreasing it by 20, gives us that 62. Does that make sense, how I formed that formula? So we're just saying a decrease of 20% of the original amount left us with 62. Okay, if you're confused, I'll do one more example of this one after this. So then to find X from this, we do 62 divided by 0.8, just a simple little rearrangement there. So 62 divided by 0.8 gives us 77.5. So this dress was originally £77.50. Someone's pointed out, so said it doesn't tell us to decrease. How do you get 0.8? Really good questions. So a 20% sale means a 20% decrease. So what we're saying here is that the sale price of a dress is £62. How do we then get back to whatever the original price was? These are really challenging questions, so don't worry at all if you're not fully getting it. Let's have a go at one more and I'll try re-explaining it through this one. So let's say a car's value increases by 13% to £1,200. What was the value before the increase? So what we're saying is some number increased by 13% gives us this. So what was that original number that we then increased? So give it a go. If you don't understand, don't worry at all. I'll go through it once a couple of people have answered. So be careful. We don't want to increase this by 13%. That's not what the question's asking. It's asking what was the original amount that was then increased to give us this. So I'll go through it just so that we have time to go through that one last question. So always when we're talking, so it's reverse percentages because we're like reversing to get back to what the original answer was. So we call the value before the increase something like x, and we say, well, we take that original value, we increase it by 13%, and that gives us 1,200. Because this is exactly what we're looking for, right? That original value that when increased left us with this. So then to work out x, we just divide that. So 1,200 divided by 1.13 leaves us with £1,061.95. Rounding that to 2 decimal places. Okay. I'm going to just I'll do this word question, and then we'll do the Kahoot. So a couple of people are asking for one more of these. I'm going to do this word question just because it's a different type of thinking. And then in the Kahoot, I think there is a reverse percentage question, and I'll go through that one once that one's been done there. So here we've got quite a typical word question. So Mr. Brown and his 2 children are going to London by train. An adult ticket is £24, a child ticket is £12, and a family rail card gives you a third off adult tickets and 60% off child tickets. So I'll go through this one straight away so that we have time for the Kahoot. So what we do here is we just look at them one at a time. So we've got Mr. Brown and his 2 children. So Mr. Brown, his ticket is normally £24, but it's a third off. So a third of 24 is 8. So if we take that away, we see that his ticket is now £16. And then each child ticket is 60% off of £12. So remember, a 60% decrease is represented by 0.4. So we can do 0.4 times 12 to see what this will give us. And we see that they're each £4.80. And there are 2 of these children. So that comes to £9.60. And then we just add these together to get the total amount. So 16 plus £9.60 is going to give us £25.60. So that was just a quick little go through a word question there, which a couple of people got there. Fantastic. A couple of people confused about this 16 here. It's because it's a third off. So you're exactly right. The 24 divided by 3 gives us 8, but then we have to take that 8 off the 24. Okay, let's hop back to that final Kahoot. Okay, so here's the game pin for this one. Again, there'll be really similar questions to at the beginning, but not the same ones as at the start. So it is a different Kahoot. And we'll see. Okay, so I'll wait until there's 28 people here, so I'll wait until there's about 20, and I'll pop the game pin in the chat as per usual. Cool, so Bola's just put the link to the Typeform survey in the chat. It looks like this. It's super, super easy to fill out as well. You don't even need to click. It's literally just enter, type things. It's really, really quick to do, won't take you long at all. So perhaps either start it whilst you're waiting for other people to join the Kahoot, or do it straight after the lesson maybe, but maybe just open that and pop it in a tab now, so that you're ready to do it straight after the lesson, because it would really help us to know what we're doing right, what you'd like in the future. Okay, let me just pop this game pin, as I said I would, in the chat here. And I'll just give it 30 more seconds or so, and then we'll get started. Okay. I think I'll start this now. I've put the game pin in the chat and it's unlocked, so you can join whilst we've started. Okay. So what is the formula for simple interest? Now, I think these might be, these are a bit differently to how I've written it. So I write it as A plus NAM. So in this case, P is the original amount, R is the percentage increase, and N is the number of years, I believe. Oh, I was incorrect. Okay, well, we don't like that question anyway because it's not how I expressed it. So, I take out a loan to buy a $5,000 scooter. If a 10% deposit is paid on it, how much is owed? So that means 10% has already been paid. So how much is left to pay? Sorry about that first question. I'm going to ignore that in the final results. I should have changed that to fit my own things. I always grab these quests, pull them from different Kahoots. Excellent. So it was basically just finding 90% of this. So we can multiply it by 0.9. So a little percentage increase question. See if you can do this in just one step on a calculator. So what do we need to multiply it by? I'll just wait until this goes down to 30 seconds, so get your answers in by then. Brilliant, well done. So this is just 130 times 1.4. Now, same number, we want to decrease it by 65%. So think about what the multiplier will be there. Again, I'm going to skip this when it gets down to 30 seconds on here to get your answers in by then. Brilliant, well done. So here we want to multiply 140 by 0.35. So a bit of a reverse percentages question here. So what gives 22 when we decrease it by 80%? So try calling this thing X. What would you have to decrease it by? Give it a go. I'm going to stop this one as well when it gets down to 30 seconds. So get your answers in by then. Brilliant, well done guys. So here we would say, and I'll do this one quite quickly. We want to do, we call it X. It gets decreased by 80 and it gives us 22. So we do 22 divided by 0.2. So well done to those who got that one. Bit of a harder question. So again, another reverse percentages question to kind of challenge you guys. So the current value is 4,550, but that is a 30% decrease of what it was originally. There will be a math joke today at the end. People are asking that on the Q&A. Don't you worry. I'm going to stop this one when it gets down to 60 seconds. Okay, tricky one that. So we have to say that x times 0.7 gives us 4,550. So we have to divide that there by 0.7. Last question. Another reverse percentages question. I made this one super challenging, so I'm not sure how much, if the percentage will have increased, because especially because of the first question, where the formula was worded completely differently to how I like to do it. So I'll let this timer just go down to 70 this time. Brilliant, more people got that one. So we say x times 1.3, more is this year, yeah, so times 1.35, so we divide that one by 1.35. Awesome stuff. So I'm not sure if the percentage will have increased because it was harder, and also the first question was a bad one on my part. So Amani, QQ, and G. Well done. And it means that you all got them all apart from that silly first question. So let's just have a quick look. I doubt this will have gone up, but that is my fault. Let's see. Oh, hey, it went up by 1%, even though everybody got the first question wrong because it was a silly question. So well done, guys. Smashed it. So the maths joke for today that was shared by Emma is, what kind of insect is good at maths? An account ant. And it's very fitting because it's to do with financial maths like we were doing today. So thank you for coming. Please, please, please fill out that type form. It's literally just in the chat. Yeah, I will see you guys all tomorrow for a lesson on completing the square. Super important one. So try to come to that if you can, possibly. Oh, someone said that they can't see the type form in the chat. Let me just, I'll re-copy and paste it here for you. There you go. So give that one a go. Check out the MyTutor website as well. They offer loads of one-on-one tutoring. And also there's a timetable on there so that you can see what webinar is next and what's coming up soon. So thank you all for coming. Well done, everybody, today, and I'll see you tomorrow. Bye.